Take a couple minutes to make a video showing how to move in the path that's created by an absolute value function. All right, so we're going to start off very much the same way that we would if we were to create a linear function or if we were to create a parabolic function. And in fact, you might want to remix one of those other options, other programs that you created. All right, so that's kind of what I did here. I changed things up. I have my variables. Again, if you need to make your x and y variable, you click on make a variable, you type in x, you type in y, and you go from there. All right. So what I'm going to do is get when the green flag is clicked, I'm going to have my sprite go to the starting location. I already have it at that location. I have everything set up in terms of a backdrop and my sprite. All right. So I guaranteed that my sprite was a size smaller than the hole that it was trying to get into and smaller than the tee box. All right, still a little on the big side, but that's okay. All right, so for motion, I'm going to have it go to this location. All right, so I'm going to have it set x to be equal to that value. All right, so set my variable x to be equal to negative 201. All right, so and I'm going to get into my controls, my repeat until block. Now I want it to repeat until something. It all depends on the path I want to have it follow. All right, so I want it to follow an absolute value. So let's see, that's it's a V shape. So let's say I want it to go here. All right. So that would give it a vertex of 13,110. All right, so I'm gonna keep that in mind, 13,110. All right, 13. I'm writing it down. All right, so that's the vertex of my absolute value function. All right. Now in Desmos, I can just kind of rough that out and see what that would look like, but I'm just gonna get my information at this point. I'm gonna go back to my start and find the slope connecting the 2 points. All right, so we had negative 201 and 2, negative 201 comma 2, I should say. All right, so I'm going to compute the slope between those two coordinates. All right, so that's change in y. So 110 minus 2, that's 108. That's my numerator for the slope. Over change in x, so 13 minus negative 201, so 13 plus 201 is going to be 214. So 108 divided by 214, I'm just kind of roughing this out on the side, is about 0.505. All right, so I'm just going to chuck this into a Desmos calculator real quick. All right, so now the general form or standard form of an absolute value function is y equals a times, I put the wrong notation in there, a times the absolute value of x minus h plus k. All right, so the h and k values being the vertex, or giving the vertex, and the a value being the slope. All right, the issue is the slope is going to be positive if it's opening upward. It's going to be negative if it's opening downward. So even though I computed a 0.505, I want to put it in as a negative 0.505, right? Because if you think about the path that I was following here, so I wanted to do something like this and then come on down the other way. So it's an upside down V, all right? So I would want that to have a negative slope because I want it to have a negative, I want it to go downward, right? Upwards then downwards, all right? I would get my vertex in there, which I had said was negative 201, no, that was my start, 13, comma 110. All right, so I got to do a lot of zooming out because these are pretty large numbers, but that's what we're looking at. All right, so that sort of fits the path that I was talking about. Our initial coordinate was negative 201 comma 2, so let me plot that in there. Let's see where that would be. If I kind of line this up so that it sort of looks along the lines of the way it did in Scratch, it kind of feels right. Right, so I think I could work off of this. Right, so I have all my ingredients. As long as I know the model that I'm working off of, I'll be in pretty good shape. Right, so I'm gonna have to build this using the Scratch block coding along with these coefficients. All right, so I'm gonna repeat until what? Well, it depends on where I want it to go. So I'm just gonna throw in a number in this neighborhood. So let's say 210. All right, so let's go to an equals, we'll say 210. Because honestly, I don't know where I want it to go just yet, but we'll see. I'll be tweaking this definitely. Almost sure of it. So set y equal, that's where we're going to come up with our relation. Now you see we have an absolute value right here, so we're going to need that. All right. So the absolute value of something, well, if we're going back to this model that we're using, it's going to be x minus h, and we're going to have a product of that with an a. All right, so I need a minus. Oops, double clicked for some reason. And I'm going to need a product. All right, so x minus, it was x minus 13. All right, and that was multiplied by negative 0.505. So let's get that in there. So x minus 13, that's in the absolute value. That whole thing is multiplied by negative 0.505. Then, looking back, we see that we added a k value to that. That k value was 110. So let's get an addition. Oops. Get an addition, throw in a 110, and then chuck this right on in there. All right, so now I have an absolute value equation. I'm going to pop that in there. Everything else is going to be pretty much the same as what you would do with a linear, all right, or a quadratic. All right, I want to go to the location based off of the x values that we've come up with here. All right, so in my motion, I'm going to go to xy. I'm going to create some sort of change. Most of the time we go by ones, but if you want it to go a little faster, you can vary your speed by changing the increments in which you go by for x. Right? So if you want to go by twos, you can make it go a little faster. I can show you that in a second. All right. And then once it hits negative 210, I'm sorry, positive 210, then we'll be there. So let me hit the green flag, and you see here it's moving. It's cruising along. Then it hits, deflects, or reflects, and it gets to this location. All right, and then it's just a question of what I want to do when I get there. All right, now maybe I wanted to go a little further. Maybe I wanted to go a little further and a little faster. All right, so put a little extra oomph onto it. Now let's say I wanted to go by twos. If I go by twos, then if we start off with a negative 201, it's going to count in terms of odd numbers, so it'll never end at an even number. I'll show you real quick. It's going a little faster. Got that nice deflection. And then you're like, oh, it's not stopping. Why is it not stopping? It's because it never developed or never determined truth based off of, or at least a true statement. It's not a question of whether x is going to be more than 210. It's a question of, will x ever be equal to 210? There's never a situation in which it will be, under these circumstances, equal to 210 if we start off at negative 201 and add 2 repeatedly. All right? We'd always land on an odd number, never landing on an even number. So it never gets to a point. It's repeat until that happens. Well, it never happens, so it's going to keep repeating this operation over and over and over again until the end of time. So there's 2 ways to handle this. 1, change your start. 2, change your end. All you'd really have to do is make this an odd number. So make that 211. So it's going a little bit faster. But now it comes to a stop because it can satisfy the condition of landing on an odd number. Now, if you really want to get a little, crazy with it, you can go by. You can change your x to go by 3s if you want to go faster. But then you got to make sure that your repeat until lands on a value that is a multiple of 3 beyond the negative 201. All right, so you'd have to play around with that. So basically, if you hit the green flag and it goes on forever and ever, odds are your repeat until value is incorrect. All right, so that's how you can do an absolute value. Now, from here to get to the whole, that's a different story. Maybe you want to do another absolute value. Kind of bounce off of the wall here. All right, maybe you want to do a linear function. It would have to not be vertical in order to be a linear function. All right, you can't fail the vertical line test. All right, but you can give that a shot. I mean, you might try to do a sideways parabola. You might want to try to do a radical function. There's a lot of different possibilities from here. All right, so but that's beyond the purpose of this video.